Hello, welcome everyone. My name is Leila Rhodes and I'll be your moderator today. Thank you so much for joining us here at NetCom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's webinar, Start Your Network Foundations with CCNA. Presenting today's topic is Robert Piper. Robert is a well-versed Cisco Certified Subject Matter Expert, having over 35 years of experience in the information technology industry, and he has provided corporate training, including hands-on and virtual practice labs that feature the latest Cisco equipment. He has delivered several training programs on data communications and networking, CCNA, FCC, fiber optics, IPTV, basic electronics, and MS Office. Robert is one of the most experienced instructors with a proven track record and impressive student feedback. He is known for his expert dealing with students of varied backgrounds in an engaging, easy to understand, and experiential way. Now, please bear in mind that this is just an overview of a very robust topic, and we do offer a collection of technical and business courses that can be tailored towards your specific requirements. And if you're interested in further discussion about any of those, you can make an appointment with our learning consultants through our website at www.netcomlearning.com. NetCom Learning helps customers build an innovative learning organization by achieving a smarter workforce, adapting to change, and driving growth. And we do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We have 9 practice areas in which we specialize, and they encompass people, process, and technology training. Today's presentation is from the networking practice area. NetCom Learning offers a comprehensive training portfolio for networking courses, and our upcoming classes include various training on Cisco Solutions, CCNA v1.0, Enterprise Network Core, Cisco Cybersecurity Operation Fundamentals, and many more. And private training to teams is also available, and those learning plans can be customized to the specific needs of the audience. You can also access a variety of network marketing assets, such as the free 1-hour training, free on-demand training, and blogs by clicking on the available webinar handout. And these offerings can also be found with a simple search on our website at www.netcomlearning.com. In this webinar, we will explore and learn about network components such as switches, routers, wireless LAN controllers, troubleshooting, managing network devices, identifying basic security threats, and much more. And now I'm going to go ahead and pass the time over to Robert to present today's topic. Hello, Robert. How are you?
I'm good. Thank you for the introduction, Layla. Can you see my screen?
I can see it.
Fantastic.
Perfect.
Let me talk briefly about what to expect this afternoon. We're going to give you an overview of our CCNA course. I'm actually going to be teaching that class. So if you want to get in that class and you want me to be your instructor, that would be the class to get in. All right, so we're going to introduce you to networks. We're going to talk to you about some of the components that make up our networks. We'll give you a brief introduction to the components that make up our local area networks. We're going to talk about IP. We're going to talk about the role of a router. We're going to compare and contrast that briefly to what a switch does in the local area network. We'll introduce you to system monitoring with an introduction to SYSLOG. And then we're going to talk about troubleshooting as well and give you a brief overview of security and how we mitigate against some of those security threats that are out there. So again, this is just an introduction. We're going to highlight a few of the topics that we talk about and go into more depth in our actual course. And hopefully we'll see you guys there on the 18th. So as an introduction to networking, we've heard that term networks a lot, right? We've got social networks, we've got professional networks, we've got personal networks and computer networks. But specifically within the IT industry, if you were to simplify the definition of a network, it consists of 2 or more devices that are connected together to share or exchange resources. Resources including printers, files, anything that will allow for electronic communication. And that link could be through cables, it could be through the telephone lines, radio waves, or even infrared light beams. Now, some of the more well-known types of networks would include a personal area network. That's a network that's formed around you or I as an individual. It may consist of our desktop PC, maybe a mobile phone, and we use that personal area network to establish communications for connecting to the digital network and to the internet. We got a local area network, which is a group of devices and peripherals that are connected in what we call a limited area, like a home office, perhaps a school environment or laboratory. It's also used to share resources, including printers, files, gaming, applications, things of that nature. We've got a wireless local area network that helps you link to a single or multiple devices using wireless communications, also in a limited area like a small office, home office. Then we've got a larger network that we refer to as a metropolitan area network, or MAN, that consists of a network that spans an entire city or perhaps a college campus. We've got a wide area network, which spans across a large geographical area. And one of the things that we'll do when we're teaching is we'll point out from a testing perspective, what are some of the buzzwords that you should remember? And this is one of them, over a large geographical area when we're talking about a wide area network. And that wide area network typically connects local area networks to other local area networks using telephone lines, radio waves, or connection through a service provider's WAN, for example. Then we also have storage area networks, which is a type of network that allows for consolidated block level data storage. And then the last one I'll mention is a VPN. That's a private network that we use to get connection over a public network infrastructure, like your service provider's network at home through your home office. That VPN uses virtual connections that are routed through the web through a third-party service or service provider's WAN. It's a free or paid service that keeps your web browsing secure and private over your public Wi-Fi hotspots, as an example. Now, I want to go over this because in that CCNA course, we talk about the various components and areas that are included on this slide. So I wanted to share some things so that you could understand the language that we're talking about, because in IT, isn't it about speaking the same language? So in an effort to accommodate the need for modularity, particularly when we design our networks, what Cisco has done is they've developed this enterprise architectural model that gives us all of the benefits of a hierarchical network design within a campus infrastructure, facilitating the design of a larger, more scalable network. Now, this module separates the network into functional areas called modules. And it's this modularity that's built into the architecture that allows for flexible network design. It facilitates the implementation and troubleshooting of our network. So let's investigate this model in a little bit more detail. So we've talked about the entire, or I should say the enterprise campus. That's usually a large site that perhaps is the corporate headquarters of a Fortune 500 company. Then we've got things like the remote site, we've got the branch office, we've got the small office, home office. Maybe we've got mobile workers that have to connect to the enterprise campus to share resources and information. And then if you look closely, included inside of the enterprise campus is the data center, the LAN core, as well as the LAN access modules. Now, in the data center, and you may have heard this referred to in the past as a server farm, that data center is responsible for managing and maintaining the systems that are vital to most modern business operations. So employees of companies, partners of companies, customers, they all rely on the data as well as the resources that are located in the data center in order to effectively create, collaborate, and interact with each other. Inside the enterprise campus, too, is another module called the LAN core. That's the place where our high speed or high performance switch backbone connects to other buildings and various parts of the campus. So this layer provides redundancy. It connects our LAN access module with the data center module. It routes and switch traffic from one module to another. You'll see multi-layer switches for high throughput while adding routing, quality of service, and other security features. And it's this high capacity centralized data center module that provides users with access to our internal server resources, including applications, file and print services, email services. And we also support network management services in the enterprise that might include system monitoring, system logging, and also troubleshooting, which we'll talk about in a few minutes. And within the enterprise campus, the LAN access module grants end user devices access to the network. So in a WAN environment, it'll provide remote site, branch, or small office, home office access to the corporate network across the web or across a WAN connection. Now, this slide shows us some of the components of a network, including switches, routers, wireless APs, or access points. They're all essential networking bases, and it's through these devices that allow you to connect to the corporate network so that you can communicate with one another and within other networks like the web. So switches, routers, wireless access points, they perform very different functions within the network. Let's talk about the switch. That's at the foundation of most of our business network models. It acts as a controller that allows us to connect peripherals and printers and servers to the network in that campus and allows us to communicate with each other as well as other networks, creating a larger network of shared resources. We've also got a layer 3 switch here that combines the functionality of both a switch and a router. It acts as a switch to connect devices that are on the same subnet or VLAN. And it also has routing intelligence built in, so it doubles as a router. So it can support multiple protocols, it can inspect incoming packets, it can make routing decisions based on the destination IP address. We call that a multi-layer or layer 3 switch, and it adds a ton of flexibility to the network. One of the other things that we point out, however, is for the purposes of the course, the CCNA course, as well as the CCNA exam, what Cisco wants you to do is they want to make sure that you understand what's a switching function at layer 2 versus what is a routing function at layer 3. So although we talk about what a multi-layer switch is or a layer 3 switch, we're going to talk about switching as being a layer 2 function and routing being a layer 3 function. Also, a Cisco iOS intrusion protection system. That is what we refer to as an inline deep packet inspection feature that assists us in mitigating a wide range of network attacks, that provides you with the tools to be able to accurately identify, classify, and then block malicious traffic in real time. We've also got a firewall as part of our network, which is a security appliance that monitors inbound and outbound network traffic. And based on rules that you predefine, it allows us to block specific traffic based on those defined sets of security rules. Essentially, what this appliance does is establishes a DMZ or a barrier between the secured and controlled portion of your network. We call that the trusted portion of your network, and the outside or untrusted portion of your network, like the internet or your service provider's WAN. And one of the benefits of incorporating a firewall is that it can be hardware or software or a combination of the two. Next, we have a router that is what allows us to connect local area networks together. It also allows us to connect from our intranet to the service provider's WAN. We'll talk a little bit more about the role of a router. What else do we have here? We've got a VM, which is a virtual machine that functions as a virtual computer system. It has its own virtual CPU, memory, network interface, its own storage, but it's created on a physical hardware platform. There's software or an application called a hypervisor that separates the machine's resources from the hardware, and it distributes them appropriately so that they can be used by the virtual machine. The physical hardware that's equipped with the hypervisor is called the host. So you can have many virtual machines that uses its resources as guests. And VMs are isolated from the rest of the system, so you can have multiple VMs on a single piece of hardware, like a server. You can move them between host servers depending on the demand, or to use resources more efficiently. Then finally, we'll talk about the access point. That is what we use to allow for wireless connectivity without cables. It makes it easy to bring on new devices online and gives us the flexibility to support our mobile workers. It acts like an amplifier of your network. And then we have a wireless LAN controller that manages our wireless access points in order to configure and allow those to connect folks wirelessly. Now let's talk about IP, or specifically the internet layer, which is the second layer of the TCP/IP protocol stack that we'll talk about. The main functions of the internet layer are to transmit data to and from the network access layer, routing data to the correct destination network on the appropriate network, and then handling things like packet errors and network fragmentation. Routing is the process of selecting the best path in the network along which to send an IP datagram. And then those datagrams are encapsulated within what we call an Ethernet frame or an Ethernet packet, depending on which layer of the OSI we're talking about. Now, the TCP/IP internet layer, it functions like or is a direct correlation with layer 3 in the OSI model, the network layer. So what we do in class is we go into a lot of detail comparing and contrasting the OSI 7-layer model with the 4-layer TCP/IP model. We also give you some additional information that you can use as a study tool that will give you some pictures and talk about what happens at each layer. We'll give you some pictures that talk about what protocols exist at each layer, so forth and so on. So with regard to the internet layer, the major protocols include IP, or Internet Protocol, ICMP, Address Resolution Protocol, reverse ARP, as well as IGMP. And again, we go into a lot more detail in the class itself. We're giving you just a little bit of a taste as to what you'll get when you join us, should you choose to join us on the 18th. Let's talk a little bit about what a local area network is. So we've got an example here of a small home business or small office environment that can use a small local area network to connect 2 or more devices to share peripherals like a printer, right? Then we got an example of a larger corporate office that is used to connect multiple local area networks together that can accommodate hundreds or even thousands of devices and shared peripherals. It can span a lot of floors in an office complex. And in the class, we also take a deep dive into what network segmentation is, which basically is breaking up a large network into smaller pieces. We also talk about what the 3 major benefits of network segmentation are and how we define network segmentation, as well as what types of devices provide segmentation and what devices don't. We also discuss the role of a switch in delivering frames in the local area network via the destination MAC address, and how that is different from the role of a router at layer 3 that delivers packets based on the destination MAC address. So by the end of day 1, you have a really good understanding of how the switch is utilized in delivering frames in the local area network via the destination MAC address, how it does not do anything invasive to the frame that it receives. It merely extracts information in an effort to populate and maintain its MAC address table. And then when you have a frame that needs to exit the LAN, it's got to go to the default gateway. We talk in depth about what criteria is used to the network that the destination host IP resides in. And if I do, out which interface do I send it? Let me repeat it for those of you that are taking this down. I'll do it one more time. Do I have a route in my routing table to the network that the destination host IP resides? And if I do, out which interface do I send it? If you take nothing away except for that document what a router says or what a router answers when it receives a packet, you'll be better off for it. And we talk about that in depth when you come to the class. Here are some other components that are included in our local area network. We've got hosts that include any device that can send or receive data on the LAN. We've got interconnections that allow data to travel from one point to another. Those interconnections could include the network interface card on the device. We've got network media that's transmitted over, so data is transmitted over copper, fiber, et cetera, and we talk more about that as well. We got network devices that we just talked about, like the switches, the routers, the access points. We go into details. And then protocols. Those are rules that govern how data is transmitted between different components of our network. So we talk about Ethernet protocol. We talk about IP, Internet protocol. We talk about TCP, some of the characteristics of transmission control protocol. UDP, user datagram protocol. We also talk about some protocols like ARP, address resolution protocol, that resolves a layer 2 MAC address to a known IP, and how that comes into play when we have to route packets outside of our local area network. We talked about this, our hosts that include PCs, servers, IP phones, and printers, mobile phones, our NIC cards, our switches, our routers. Yeah, we just talked about this. Here we're talking about the role of the router. So the role of the router that we talked about briefly is that they route packets from one local area network to another. We talk about how the switch is responsible for delivering frames inside of the local area network via the destination MAC address. And then if we have to exit the local area network, then we've got to go to the default gateway in order to be routed. When that frame goes to the default gateway, then it answers that question. Do I have a route in my routing table to the network that the destination host resides? So let me see if I can give you an example here. Let's say that we've got a device in LAN A. Let's do this. So let's say this guy wants to communicate with Bravo in LAN B. Where does that packet have to go to be routed? It's got to go to the default gateway. When that frame hits the default gateway, the router passes that to layer 3 of the OSI model and answers the question, do I have a route to the network that Bravo resides in? In this case, it does. It has a directly connected network or a directly connected route to the 1022 subnet, which is where Bravo is attached. And if I do, out which interface do I send it? So it sends it out this interface here on its way to the switch, which then looks at the destination MAC address and then forwards it out the appropriate port on its way to Bravo. Now, here's the output of the show IP route command on a Cisco router. Here's the directly connected route that shows up with a C on the left-hand side. The R is a route that's been identified by the RIP routing process. O is a route that's been identified by the OSPF protocol. D stands for dual algorithm. So that's a route that's been identified via EIGRP. We talk about static and default routes. So this static route, we talk about the benefits and value of a static route. This S with an asterisk is a default route. It's what creates this gateway of last resort. And we also talk about what all of these zeros mean. So those zeros are what's referred to as a wildcard mask. So we go into detail about what a wildcard mask is. If you look closely to these brackets as well, you'll notice that this first number, the 120, the 110, the 90, that is what we call an administrative distance that rates the trustworthiness of the source of the routing information, which is used to identify the most appropriate route when you have more than one route to the same destination network. So we talk about that as well. The other thing that's really nice is that we not only do lecture, but we also follow up with an actual hands-on lab so that you can make practical application of the information that we're sharing via the lecture portion of the course. And in all honesty, our students over the last few years have told us that they want more lecture, or excuse me, more lab. And so what we've done is we've reduced the amount of time that a guy like me is talking in front of the class, and we've given you more lab time because that's what our students have said that they required. So we give you a lot of lab time. As a matter of fact, I think there's a total of about 35 labs, which is about half of your 5 days that you actually get to make practical application of the information that we actually discussed through the lecture portion. All right, we'll talk briefly about our troubleshooting methodology because let's face it, that's a process that leads to the diagnosis and hopefully a resolution of a problem. And that's usually triggered when somebody picks up the phone and says, hey, I've got a problem. So this slide illustrates the components or the primary elements of what we call a structured troubleshooting approach. So we've got gathering information that happens after the problem's been reported by the user. This might include interviewing all of the parties involved, gathering other relevant information. We've got, after we gather the appropriate information, we've got to analyze it. We've got to compare the symptoms against what we understand with regard to the processes, the baseline, so we can separate what's normal behavior from what might be abnormal. Then we need to eliminate potential causes by comparing the observed behavior against the expected behavior, so we can eliminate some of the problems. Then after gathering and analyzing information, eliminating the possible causes, we might still have one or more potential problems. Then we have to assess the probability of each of these as the most likely cause, and then testing our hypothesis to confirm or deny that it's the actual cause of the problem. So the simplest way to do that is to propose a solution based on our hypothesis, implement that solution, and then verify whether or not it solved the problem. Again, we need to keep in mind that if testing our hypothesis is disruptive, we may need to do that at an off hours time or something of that nature. Now, the main takeaway from this slide is that if we don't take a structured approach and we go through the troubleshooting steps in an ad hoc fashion, we might eventually find a solution, but that process can be very inefficient. It also is challenging if we need to turn that issue over to somebody else or let somebody else put their eyes on it. How many times have we been in the middle of troubleshooting an issue, and then for some reason we're just racking our brain and we don't get it, and we call a buddy of ours and go, hey, take a look at this. I've been killing myself all morning and I can't see it. And because we get some fresh eyes on it, they look at it and go, oh, here's your problem right here. And you just throw your hands up going, hey, I did not see that. So it's a lot easier if we take an actual structured approach like we're proposing here on this particular slide, so that if we need to get somebody else's eyes on it, we can certainly do that. Here's some other troubleshooting methodologies: the top-down approach, the bottom-up approach, and the divide and conquer approach. All of these you can probably see have the OSI 7-layer model. Now, the layer that we go into a lot more detail about each one of these, but the bottom line is that the layer that you ultimately select as the first targeted layer is the one that's faulty, then you know that the layer below it's in good working condition. So when you take, for example, the divide and conquer approach, it's based on your experience level, perhaps the systems that you've gathered about the problem. So for example, if a user reports that he can't go to or has some trouble with a particular web page, but he has no trouble going on to other web pages, then what you might safely conclude is that you don't need to begin troubleshooting at the physical link layer, the data link layer, or even the network layer. But if you've got a number of users that report that they're having a problem accessing all resources on the web, then it might require that you start at the network layer and then take the next steps based on those findings. Now, the first step to understanding how your network is performing is by gathering as much information about the network as possible. So often the existing documentation doesn't provide enough information because you might have more recent information about the condition of your network. This is where network audits, traffic and events analysis can provide information that you might need, where system monitoring type of tools become important. So system monitoring is a good way to get an overall picture of the network so that it can help you to recognize quickly different issues so that you can ensure that the network is performing as it should. It'll also provide proper network performance baselines so that you can have a comparison tool when you have to troubleshoot, like we just touched on over the last few slides. So situations where several hardware device failures are only noticed after a few days, that type of thing should never happen. So we'll talk briefly about SYSLOG, because as a networking admin or engineer, you're going to work with system monitoring tools a lot, and you need to get a firm grip on the purpose of time synchronization, how important it is to have time synchronized on all of your infrastructure devices, the structure of the iOS system messages, how and where they can be stored so that you can analyze those later. And also, you need to have some familiarity with SNMP so that you can monitor the performance of your network device. So this slide, if you look closely, talks about some of the syslog components that are used to collect system logs that contain critical information about things like the status, error, warning, configuration logs, and so forth of our Cisco routers and switches. And it's syslog that's used to track these system logs and the alerts. So you've got a syslog listener that gathers and processes syslog data. You've got a syslog server that stores the massive amounts of data that's collected so that you can retrieve it. And then you have to have some sort of management and filtering software. Because of the enormous amount of data, it can take an excessive amount of time in order to identify a specific log entry. The syslog server will help to automate that type of work, and it'll assist you in filtering a view so that you can look at specific log messages. To illustrate, it can extract messages based on parameters like device name or event time. You can also use the filter to avoid seeing certain types of entries through the negative filter rule. And if you wanted, you could show all of the critical log messages from a firewall as an example. And imagine if you have a large network that has a lot of switches and routers, a dozen servers, and a number of workstations. Wouldn't it be great if you could monitor all of those devices somehow? Well, back in the 80s, some smart folks figured out that we should have something to monitor all of our network devices. The idea being that most of our devices, things like PCs, printers, routers, all share some similar characteristics. They all perhaps have an interface, an IP address, a host name, and so forth. So what these folks did was they created a database with variables that could be used to monitor different types of network devices. And this resulted in what we call simple network management protocol. And we go into a lot more detail in our 5-day course. So management and maintenance of our routers and switches, our applications and configurations, all begin with understanding the sequence of events that takes place when we turn a piece of equipment on. Our operating system is loaded and the configuration is applied. So as a networking engineer, you need to be able to manage different devices, operating systems, configuration files. You need to be able to troubleshoot the boot sequence of your routers and switches. You need to be able to perform backups of the iOS image and configuration files. You need to be able to check the images for consistency and also upgrade the system images when required. One of the things that you can utilize is the iOS file system feature that gives you a single interface for all of the file systems on your router, including your flash, your network file systems like TFTP and FTP, and any other endpoint for reading or writing data, like your non-volatile RAM, your running configuration, your read-only memory, or your microcode. So with IFS, all of your files can be viewed and classified as either image or text files, including files perhaps on remote servers. So for example, you might want to determine the size and type of an image on a router prior to copying it down to make sure it's valid. You can also display configuration files on a remote server to verify it's the correct configuration prior to copying it over to the local router. Here's an example of the Cisco iOS file system. It identifies the flash file systems in the router, the different types, the different flags. We go over these flags and their meaning, the read-only, the read-write, the write-only, etc. Here's the stages of the power on self-test, for example, or when we first turn on. During the boot process, that iOS is copied and then decompressed in RAM from flash. The running configurations also copied in RAM from non-volatile RAM. RAM stores the ARP table, the CDP neighbor table, the routing and other tables. And so the router goes through 3 steps when we turn that router on. It goes through the power on self-test to make sure everything's included and up and functioning properly. Then it goes through a process where it locates and loads the iOS. Then it locates and loads the device configuration file. And we go into a lot more depth during that 5-day course with regard to the various stages of the boot sequence. I'll finish up with a brief security overview, and then we'll open up the lines for questions that you guys might have. Now, securing the network requires securing access to your infrastructure devices, because when access is compromised, then the security and management of the entire network is vulnerable. So what we do is we go through a number of different threats. Some of the things that you see on this particular slide, like remote access threats, local and physical threats, environmental, electrical threats, and maintenance threats. And we talk in depth about how to mitigate against these threats. We also talk about some of the methods to obtain passwords, like guessing, dictionary attacks. We talk about how important it is to maintain an updated password policy. We also talk about some of the alternatives to passwords, like multi-factor authentication. That is a security system that verifies a user's identity by requiring multiple credentials. You probably have seen that when somebody wants to use MFA, they'll send a code to your smartphone, for example. So you'll have to click on the messages to utilize that to get in somewhere. We also have digital certificate, which is an electronic password that allows you and I to exchange data over the web using what's called a public key infrastructure. And then we've got biometrics, which is a way to authenticate and provide access based on some sort of physical characteristic. And because it evaluates a bodily element or some sort of biological data, it's probably the most strongest and foolproof physical security that's used currently. We talk a lot more about that. And then we've also talked in detail about some of the emerging threats, computer viruses, worms, botnets, some of the phishing attacks or social engineering attacks that's designed to steal our login, our credentials, our credit card information, and other types of personal financial information. We talk about distributed denial of service attacks. Those are attacks that are designed to overwhelm the servers with requests for data, making them inoperable. And research has told us that over 67% of businesses have been attacked by ransomware and have lost part or all of their company data. So it's not if, but more like when. So we need to make sure that we can mitigate against some of these attacks, because remaining educated on the latest cyber threats is going to be the first step in improving your security processes and combating these malicious attacks. And so You and I have to remain vigilant in keeping all of our system hardware and software up to date. We've got to be actively monitoring our network utilization, our usage, our internet security measures, our anti-malware, antivirus solutions to make sure that our organizations that we support can battle whatever cybersecurity threats come down the pike. I hope you guys enjoyed that brief overview. I kind of talked kind of fast, but now I'd like to turn it back over, and then perhaps we can come back to me for any questions that anybody has.
Thank you. You are always so thorough, and I know there is so much more information that we could actually get to. However, obviously we've got quite a few people in attendance, so I'm sure they're going to have some questions for you. We're going to take a quick moment to hear from Mary. Mary is our product manager, and she's going to introduce some of our promotions and webinar related courses.
Hello, Leela.
Hello, welcome. Thank you for joining us.
Thank you. And that was a great session. I guess so much to learn about Cisco. And what I want to do in the next few minutes while you're logging in your questions, I'd like to bring you to the website wherein you can get more information on the different courses and certification that Cisco has. Cisco has several tracks that you can look into depending on your job role. So I'd like to go to, this is our website, netcomlearning.com, and you can actually just go to the Cisco vendor page. So just moving on to that, if you go to the vendor page, you can see various assets wherein you can get more information about the different technology track. So as you can see here, Cisco has the associate level wherein you can start off, kickstart your learning, whether you have your CCNA, which normally starts off your networking training. And for the developers in you, there Cisco has added about a couple years back the DevNet track. And then for security professionals, you have your cyber ops, you have your specialist, and then the professional level, which provides you different options on Cisco because there are different roles even on the solution areas or the technology tracks that Cisco has. And if you go to, say, for example, the enterprise, then you can see here all of the courses that you can get. You have to pass the core exam. This is the common body of knowledge on your enterprise, which is your encore. And then you can choose depending on what makes sense more for you, right? For if you need more on advanced routing and switching, or you're delving on wireless, SD1. So there are different instructor-led courses that you can take. Now, if your team prefers self-paced training, Cisco has e-learning library as well that you can take advantage of. So going to our website again and clicking on training, you can go to our e-learning library and pick Cisco. There is a special package that you can take advantage of. And going through this page, you can see here that you can pick, if in case you need just one e-learning, you can actually buy from here. You can read the outline for this and directly enroll in this e-learning. Each learning has 180-day access, right? Now, if you're responsible for a whole track, you can also purchase the all access pass. So this allows you to purchase packages for enterprise, for security, for data center, collaboration, and DevNet. Now, what's the beauty of this is that with one price, you have access to all of the self-paced e-learning for this particular track. And typically, you may be wearing several hats, so you may be needing different skills to achieve your work. Now, if you want the bigger all access subscription, then for the price of $87.95, you have access to all of these. If you look at it price-wise, for $5,995, you're able to access all the e-learning. Each e-learning normally costs you about close to 2,000, but here with one price, you're able to access them and at one payment. So I would encourage you to review this information, as well as if you need more guidance from our learning consultants, I would advise you to email webinar@netcomlearning.com. Another thing that I'd like to visit, lastly, go to our promotions page and see what are some specials that we may have for you that you may be interested in. And lastly, I'd like you to visit the NetCom Plus if your company would love to or are used to buying subscription. Then NetCom Plus is our subscription, which is combining ILT, instructor-led class, and e-learning. So that's over 140 instructor-led courses that you can access for a year, as well as the 250 e-learning that's included in that. Again, the best way, email webinar@netcomlearning.com, and we will ensure that we um, get you with our learning consultant to answer all your questions and guide you with your skilling. Leela, thank you for the time. I turn it over to you.
Thank you so much. Well, with that being said, we're going to go to our questions. Mary, before you do jump off, we do have the usual question that we get, wanting to know if there is any certificate for the webinar, and if so, how they would go about claiming that.
So all the certificates that you may have is actually found in your NetCom 365. So on our website, let me just quickly show that if you don't mind. If you have a profile here, chances are you have, because you have signed up for this webinar. Just go here, sign up, and on course completion or course completed, you can see there an icon for the certificate. So you can download it from there and present it to your boss, or shout it out in your LinkedIn profile. You know, everybody's doing that. So, and if you have any question, again, please feel free to just email that same alias, webinar@netcom. But do explore the benefits that you can get from our NetCom 365. There's some free e-learning there from AWS, and also gives you recommendation on what courses you may need.
Thank you so much. Okay, let's see. Our next question that we have, what is the difference between Ethernet and Internet? And what's the reason why on computer surfing it sometimes is slow?
All right, first question was, what's the difference between intranet and Ethernet? Ethernet is a protocol that's been identified by the IEEE, and it is a standard for different components, things like wire, cable, copper, fiber optics. Intranet is a term that we use to identify a corporation's network. So all of the corporate, like let's say you work for IBM, their network, their worldwide network of routers and switches, et cetera, we would refer to as the intranet, as opposed to the internet, which is how we get on to Amazon and all that good sort of stuff. So that's what the difference between Ethernet and intranet is. Hopefully that answered that question.
Wonderful. Let me see. Our next question is, what is a passing score for the CCNA?
It's actually 82%. One of the things that we go through in the class, and just as a reminder, I'm actually teaching that class virtually. One of the things that we go over is, and I forgot to mention this, so this is really timely as well. It's 82%, and we go over that. One of the other things that I incorporate into the course itself is every morning, starting on Tuesday through Friday, we start off the class for about an hour answering Cisco type of questions. So I actually talk to you about a 5-step process that I've put together to help you answer a Cisco type of question. Things like, make sure you understand the question that's being asked. Ask yourself, what area of study is this asking? Is this a wildcard mask question? Is this a NOT question? Is this a subnetting question? Gather as much intel as you can from both the question and any network topology that they give you. Answer for yourself. Let me see, what's step number 4 here? What is the most appropriate answer? And we talk about what that means with regard to a Cisco type of question. And then 5, to borrow a golf analogy, stay on the fairway. A lot of times as technology people, we want to be right? So we don't have time for that. So we talk about staying on the fairway and not allowing ourselves to get distracted, because we only have 2 hours to answer those questions, and we want to mitigate against that time, and we'll give you some other little workarounds and hacks in order to successfully prep for and pass that CCNA on the first try.
That's wonderful. Thank you. So then we have one more question that we're going to take before we wrap up today. Our next question, they wanted you to quickly explain SYSLOG.
We go into a lot more depth about SYSLOG, but every device, let me say, most devices that are on our network have a logging component where we can log different things. There's a certain criteria that we can use to set up that log file, and then we can aggregate those log files to a SYSLOG server so that we can monitor and manage those logs for items of interest, so that we can, for example, understand when paper's running out of a printer, as an example, or ink is running out of a particular printer. A lot of those can be incorporated into what we can read from SYSLOG. We can also use the other tool that is automatically built into our Cisco routers and switches, which is SNMP, which is what I talked about briefly. And we go into a lot more detail about that, as well as SYSLOG during the actual course itself. But we're basically talking about aggregating log files from all of our infrastructure devices so we can take a look at those for items of particular interest.
Wonderful. Okay, so I know there are more questions that we could get to. Unfortunately, we have to wrap up because we're already about 10 minutes past our cutoff time that we're supposed to go to. As I mentioned before, if you do have any additional questions, feel free to send them to us at webinar@netcomlearning.com. And we want to thank you all for joining us today. We hope that you found today's webinar to be very informative, and we look forward to seeing you with us back again very soon. Also, feel free to tell your friends and colleagues about our upcoming webinars and other courses. Thank you, Robert. Have a wonderful day, and thank you everyone for joining us.
You're quite welcome. Thank you, guys. Hope to see you in the future. Have a great afternoon.